Good morning, viewers. Welcome to this session. This video is specially prepared for diploma students of mechanical engineering branch. And the subject that we are dealing today is solid mechanics. In the solid mechanics, the second chapter, that is simple stresses and strains. This is what we are dealing with. Though this is mainly prepared for mechanical engineering students, diploma students, this can be, it is useful even for civil engineering, electrical engineering, and not only for diploma students, BE BTech students also can utilize this video. So let us go through a PPT prepared by me, and accordingly we will go through the content. So in this video, we are only discussing about theory part. We are not going through any numerical problems. So let us get started with the simple stresses and strains. I'll share a PPT prepared by me. So here it is. And simple stresses and strains. This is second chapter. My name is Anand Padavala. I'm senior lecturer in mechanical engineering. I work in Government Model Residential Polytechnic, situated in Gajwel, Telangana state, and it comes under Siddipet district. So let us start. Stress. So let us understand what is a stress. We will be using the word stress in general English when we feel some pressure or if we have any burden, then we say I'm stressful. But this is also similar to that, but we will be using technically stress when a load is applied on a body. So what is that stress we will see? So consider a body which is subjected to an external load. Due to this applied load, the body tends to deform. Yes, when we apply a load, an external load on a body, it will, the body tends to deform. So in order to bring back object back to the original shape and size, so there will be a resisting force generated inside the body. So when a body is subjected to some load, then the body will resist to that external load. So it will try to bring back to its original position. So there will be a resisting force generated inside the body. And this restoring force or resisting force, which will be equal in magnitude and opposite in direction of the applied external force. So it has to bring back the internal force. Therefore, it will be acting in opposite direction to the applied force, and it will be equal. Then only it can restore. So the restoring force will be there. And the measure of this restoring or resisting force generated per unit area of the material is called the stress. Unit cross-sectional area of the material is called the stress. Therefore, the measurement of this restoring or resisting force generated per unit cross-sectional area of the material is called stress. So basically, stress is in the opposite direction of the external load. So this the resisting or the restoring force due to the act of the external load is called stress. So hence the stress is defined as, if we want to give a proper definition, a stress is defined as the resisting force acted per unit cross-sectional area of the body. This is what a proper definition for a stress. Hence, it is also defined as the ratio of applied load to the cross-sectional area of the body. Why? This is because the resisting force will be equal to the applied load in magnitude. Of course, in the direction wise is different because the stress is it's not a vector. Therefore, we can define the stress as the applied load to the cross-sectional area of the body. So it is denoted with the symbol called as sigma. Sigma is used to denote stress. Therefore, we can give a formula like stress sigma equal to resisting force R by cross-sectional area of the body. So cross-section to the where the force is applied, to the plane where the force is applied, and which is equal to applied load by cross-sectional area. This is a formula for stress. So what are the units for SI units for stress is, it is force by area. Therefore, force in Newton and area is meter square. Therefore, Newton per meter square is the SI unit for stress. But mostly when we solve some problems and numericals, it will be expressed in terms of Newton per millimeter square or MPa. MPa means megapascals. Pascal means Newton per meter square. Megapascal means mega Newton per meter square. So basically, if we see 1 megapascal means mega Newton per meter square, which is equal to Newton per millimeter. How we will get this formula means, this value means mega means 10 to the power of 6. Meters means 10 to the power of 3 millimeters. So 10 to the power of 3 whole square means 10 to the power of 6. So 10 to the power of 6 by 10 to the power of 6, it gets cancelled. Therefore, 1 megapascal equal to 1 Newton per millimeter square. So generally, when we solve some problems, we will get the value will be in Newton per millimeter square. So this is what a stress about. So stress is the resisting force acted per unit cross-sectional area of a body when it is subjected to an external load, and it is denoted with the symbol called sigma. Now we will go through what are the various types of stresses we have. What are the various types of stresses? So depending on the direction of load, the stresses are classified as tensile stress, compressive stress, and shear stress. So these are depends on the type of load or the direction of the load. We can call these stresses as tensile, compressive, and shear stress. So let us go through what is tensile stress. For example, take a body, it is subjected to a load P. If you observe, when a body is subjected to equal and opposite pulls when it is pulling, that means acting outside of the body along its longitudinal axis, then that force is called tensile force. We know the tensile force. So when it is subjected to a tensile force, that means two equal and opposite pulls, so then that stress induced in the body is called tensile stress. So when we apply a tensile force, that body will be subjected to tensile stress. What do you mean by a tensile force? Two pulls, equal and opposite pulls when it is pulled outside. So that is that's what a tensile stress. So therefore, this tensile stress results in increase in the length and the decrease in the cross-sectional area of the body. If you observe this figure, so when it is pulled like this, what happens? Its length will be increased. If it is a ductile material or sagging material, then it will be stretched. So its length will be increased, and consequently its diameter or its cross-sectional area will be gets reduced. So this is what it happens in the tensile stress. So it is denoted generally with sigma T. Sigma T means tensile stress. So tensile stress is the formula. Therefore, the formula for tensile stress, sigma T is equal to tensile load by cross-sectional area. So P by area. A is the cross-sectional area. This is what a tensile stress. Now, the second stress is called compressive stress. So what is a compressive stress? So when a body is subjected to a compressive load means when a body is subjected to two equal and opposite pushes, that means inside towards the body, that along the longitudinal axis, then the stress induced in the body is called compressive stress. So when a compressive load is applied on a body, the corresponding stress we will call it as a compressive stress. So this is what we have. And this compressive stress results in increase in the cross-sectional area. If you observe, when we compress, its lateral dimension, that is, it is a cross-sectional area will increase and the length will be decreased, because see, if you see, the length will be decreased and its cross-sectional area will be increased, opposite to tensile stress. So it is denoted with the symbol called sigma C. Sigma indicates stress and C indicates compressive stress. So sigma C equal to compressive load by cross-sectional area is the formula for compressive stress. Then the third stress is called shear stress. What do you mean by a shear stress? So look at this figure. When this is a riveted joint, so when two plates are joined together with a riveted joint, then we are applying a load like this. Then this is subjected to a shear load, and a shear load will act on the cross-sectional area of this rivet. So if we want to give a proper definition, when a body is subjected to two equal and opposite forces acting tangential to the resisting section. See here, this is the resisting section. This is the resisting section, and it is acting upon the tangential to the body. So then the stress induced in the body is called a shear stress. So when a load is applied, a shear load is applied on a body tangentially, then that body will be subjected to shear stress. So this is what a shear stress. And the shear stress try to shear off the resisting cross section. So when the load is applied here and the load applied here, opposite and equal, then that effect will be on this shearing section, and exactly at the center it will try to shear off when the load is more. So the shear stress acts tangential to the area. Therefore, it is denoted with the symbol called tau. Tau is a symbol for representing shear stress. So therefore, shear stress equal to shear load by shear area. This is the shearing area. So shearing area and shear load. So this is the formula for shear stress. So we have seen all the three types of stresses. One is a tensile stress, other one is compressive stress, the third one is shear stress. Basically, these stresses are based on classified based on the direction of the applied load and also the nature of load, like whether it is a tensile load or a compressive load or a shear load. Now, we'll try to understand the concept called strain. So generally in general English, we use the stress and strain for the same purpose. I'm so stressful. Strain, got strain, like that we will be using. But in technically, in mechanical engineering or in engineering in general, so stress is different and strain is different. So what is a strain? We will look into that. So let us suppose that a body is under the stress. That means when the body is loaded externally and consequently it is deformed. For example, if a load is applied on a body, then suppose that it is deformed. That means it is subjected to some stress. When, as we said, when we have learned that the stress is nothing but when a load is applied on that, there will be a resistive force, and this resistive force will try to act to regain its shape, and that resistive force is equal and opposite in the direction of the applied load. So that force by the cross-sectional area is the stress. Therefore, when a load is applied on a body, it is subjected to a stress. It will be under stress. And suppose that that body is deformed, then that means there will be some change in the dimension of the body. For example, I have a rod and I have applied a stress, tensile stress. Then what it will be subjected to, its length will be increased. That means its original length is different, and after applying load, the length will be, final length will be different. So there will be a change in the dimension of the body. Therefore, the strain is nothing but the ratio of this change in the dimension in the body to its original dimension is called strain. So whatever the change has occurred, the change in dimension to the original dimension is called strain. Whether it can be a length or it's a width, it's a cross-sectional area, it's a diameter, whatever it may be. So the change in dimension to the original dimension is called strain. So it is denoted by the letter E. E represents a strain. Therefore, if you want to give a formula, strain is nothing but E is equal to change in dimension by original dimension. So this is what a strain. So what are the units for strain? There won't be any units for strain because it is a ratio of same parameter. So dimension by dimension. For example, if you take length, change in length by original length. Length by length means there won't be any units for strain. So strain will have no units. So this is what a strain. So simply strain is nothing but change in dimension. The ratio of change in dimension to its original dimension is called strain when it is subjected to some stress. So what are the types of strains we will see? So depending on the nature of load, the strains are classified generally based on the type of stress it is subjected to. Based on that, we will be using, we will be classifying the types of strains. So you have here tensile strain, compressive strain, shear strain. Apart from these three, we have one more strain called volumetric strain. So let us try to understand what are these classifications. So tensile strain, what is a tensile strain? So imagine this figure here. So when a body is under the influence of a tensile stress, that is subjected to a tensile load, the ratio of increase in length to its original length is known as tensile strain. For example, if you take this is the original body, it is subjected to some load, and you know this is pulls to equal and opposite pulls along its axis. So F is the force that, and when it is subjected to, then the stress will be there. Because of the stress, it will be stretched. So its original length is L, and when it is stretched, the length is increased to delta L, increased by delta L. So the total length will be L plus delta L. So original length is L, and the change in length will be delta L. Therefore, that strain, corresponding strain, because of this tensile stress, so tensile strain is called tensile strain. So tensile strain equal to increase in length by original length. How much it is increased in the length to its original length. So indicated with the delta L by L. So when a body is under the influence of tensile stress, that is when it is subject to tensile load, the ratio of increase in length to its original length is known as tensile strain. And the second one is compressive strain, similar to tensile strain. Here, the load applied is compressive load, or the stress induced is compressive stress. Its original length is L. When it is subjected to compressive stress, that is compressive load. For example, if you see here, F is the compressive, equal and opposite pushes, not pulls, pushes. along the axis. So when a body is under the influence of compressive stress, it is subjected to a compressive load. That is, then the ratio of decrease in length, because of this action, the length will be decreased. Of course, the lateral size will be increased. Then we are talking about longitudinal one. So the ratio of decrease in length to its original length is known as a compressive strain. Therefore, the compressive strain is nothing but decrease in length by original length. Decrease, how much it is decreased? Because of the compressive stress or compressive load, delta L by L. So decrease in length to original length is called delta L by L. This is what a compressive strain. Then the third one is shear strain. So to understand this shear strain, just look into this figure. Here, a shear strain is measured along the angular displacement or distortion of the surface that is in the direct contact with applied shear stress forms from its original position. For example, take this block, the block. Let us suppose that this block is subject to shear load P. That means when the load is applied in the top layer and from the bottom layer, then the force that we are applying in opposite and tangentially we are applying, that means the force applied here is shear force. So therefore it is subjected to a shear stress because the force is applied tangentially. Then suppose that it is deformed, then the deformation will be like this. The upper layer move like in this direction and the lower layer will move like in this direction. There will be some distortion. There will be an angular displacement will be there. And how much angle it is distorted. This is, for example, phi is the angle of distortion or angle of angular displacement. Then the measure of this angle, the angle itself is called shear strain. How much it is distorted or displaced angularly, angle wise, then that is called the shear stress. Therefore, shear strain is nothing but phi is nothing but. So if you want to calculate it, measure, for example, this is delta x and this height is h. If you say, if you take tan theta is opposite by adjacent. So tan phi is equal to delta x by h. But because it is the distortion will be very smaller. When we measure a strain, we can't see with our naked eye. So it will be very small amounts. Therefore, because of very small amounts, tan of some angle of very small amounts will be nothing but that angle itself. Therefore, shear strain is nothing but phi, which is equal to delta x by h. So this angle is called shear strain. So shear strain is the measure as the angular displacement or distortion of the surface that is in direct contact with the applied shear stress from its original position. So this is what a shear strain. And the fourth one is volumetric strain. What is all about? Volumetric strain. For example, take this figure. This is initial volume is V1, that is dashed ones is the original. For example, that is the original volume. And when it is subjected to a load, for example, this block is subjected to load from all directions of the same load. That means F value from all its faces. And suppose that it is compressed to some final volume. So the change in the ratio of the original volume to its final volume, change in volume to, its change in volume to its original volume is called the volumetric strain. For example, here it is the initial volume and this is the final volume, and the change is V1 minus V2. and its original volume is V1. So volumetric strain is nothing but V1 minus V2 by V1. So if you want to give a definition equation, volumetric strain, it is denoted with EV. EV is nothing but volumetric strain. So EV is nothing but a change in volume to original volume, delta V by V. Delta V is change in volume and original volume is V. Is what we have. Now, these are the strains. Now we will go through mechanical properties of material. Let us go through what are the various mechanical properties that will come across when we talk about materials. So engineering materials materials that are used for fabrication, for manufacturing, or for production, whatever it may be, whatever the materials that we use. So generally they are called engineering materials. And what are the various mechanical properties that we have? We know that different types of properties are there: physical properties, chemical properties, and mechanical properties. So what are the various mechanical properties? So to finalize the material for an engineering product or application, we should have the knowledge of mechanical properties, because whether it is why this what is the importance of mechanical properties? The mechanical properties of materials are those which affect the mechanical strength and or material strength and its ability of the material to be molded in suitable shape or to be machined into a useful product. So these are the things then we will be talking about. That is why knowing of mechanical properties of material is very important, because it when we fabricate, when we manufacture some products, so what is the strength of the material, what is the whether we can it be molded into a suitable shape or size, whether it can be machined or not, all these questions will come in. So all these things will deal with the mechanical properties. So some of the typical mechanical properties are of engineering materials are listed below: strength, ductility, malleability, hardness, toughness, brittleness, impact strength, fatigue, creep resistance, resilience. So there are other mechanical properties of this. These are the typical ones, important ones. So we will try to know what exactly these are. So we'll go one by one. So now strength. What is the strength? So the strength of a material is the ability to withstand an applied load without failure or plastic deformation. So when we can say a material is a strong material or its strength is good, so when a load is applied on that, when it is not failed or it is not deformed, then we say that its strength is good. Therefore, the strength of a material is its ability to withstand an applied load without failure or plastic deformation. This is what is strength. And this strength is further classified into three things: tensile strength, compressive strength, and shear strength. So here, based on the load that we apply, so tensile strength of material is the maximum amount of tensile load or loads tending to elongate that it can take before failure. That means, so when it is subjected to tensile stress, how much maximum a material can bear that load before it elongates or tending to failure. So that strength, how much it can bear, that tensile load, that then it is called tensile stress. When the load is compressive load, the ability of the material to withstand loads tending to reduce its size are compressive loads, how much it can resist the compressive load. That compressive load is called compressive strength. And shear strength is the capacity of the material to withstand loads tending to shear without failure. That means when the load applied is tensile, then the strength, relative strength, is called tensile stress strength. And when the load applied is compressive, then the corresponding strength is compressive strength. When the load applied is a shear stress, and the corresponding strength is called shear strength. So basically it is an ability to withstand an applied load, whether it may be tensile, compressive, or a shear, without failure or a plastic deformation. This is what a strength. Ductility. What do you mean by ductility? Ductility is the ability of a material to deform under tensile loads. So certain materials will elongate or deform under tensile loads. So ductility deals with the tensile loads only, no other loads, neither compressive nor shear. It is only deals with the tensile loads. When a tensile load is applied on a body, if it deforms, the ability of deformation is called ductile. So when a tensile load applied on a body, when it is deforms under tensile loads, so that deformation or increase in length happens, then that ability of material into that deformation is called ductility. And this is a very useful property, and this is often characterized by the material's ability to stretch into wires. How can we make wires? By stretching it, so by reducing its size. So we want to reduce the diameter, it will be under tensile stress. So making this property will be used, material's ability to stretch into wires. Malleability. It is opposite to ductility. So in the ductility, we will be using tensile loads. In malleability, we will be using compressive loads. So often we will be asking what is the difference between ductility and malleability. Both is the ability of material to deform, but in case of tensile, in case of ductility, it is under tensile loads. In case of malleability, it is under compressive loads. So the malleability is the ability of a material to deform under compressive loads. So this is what we have. And it is often characterized by the material's ability to form a thinner sheets by hammering rolls. If we see, we want to make a thicker sheet into a thinner one. So it should be compressed. It should be under compressive loads. So when it is sent through rolls, then it will become thin. So that means it is subjected to a compressive loads. So ability to be making into sheets is nothing but malleability. The third one is hardness. Hardness is the ability of a material to withstand against indentation, abrasion, or scratching. So when we say that a material is a hard material, when we try to scratch on that, no scratchings are there. When we try to hammer on it and no indentations at that particular place is there, or abrasions, no wear and tear at a particular place, then we will call it is hard material. So the hardness is nothing but its ability of a material to withstand against indentation, abrasion, or scratching. This word. Do you know what is the hardest material in this entire world and the universe? Diamond is among the hardest substance to known to man. So diamond is hardest material. That's why they will be using a diamond point for glass cutting or for any type of where we want to use cutting purpose. So we will be using a diamond to cut a hardest material. So this is what we will have. So diamond is the hardest material that is known to man. Next property is called toughness. Generally, the toughness and hardness are used synonymously in general English, but toughness is different from hardness. So toughness is the ability of a material to absorb energy and plastically deform without fracture. That means whenever a load is applied, if the material is able to absorb whatever is, When a force is applied, that means that it is subject to some energy. If it can absorb without fracture, so then that is called toughness. So material should be made tough because it should not fail. So the ability of a material to withstand against failure, fracture, so then we will call it as a tough material. Hardness is ability of the material to withstand against scratchings, indentation. That is a localized one. Whereas toughness is the overall property of a material. This is what we have. It is also defined as the material's resistance to fracture when it gets stressed. This is what we have. And the next one is brittleness. What do you mean by brittleness? Its tendency of a material to fracture or fail upon the application of a relatively small amounts of force with no or very plastic deformation. Example, if we see a glass, when a glass is subjected to some load, without any deformation, it will break. There won't be any plastic deformation. It will immediately. And also if you take a cast iron, when we try to pull it out, when we apply tensile load, it will break immediately with a very negligible deformation. So it's a tendency of the material to fracture or fail upon the application of relatively smaller amount of forces with no or very less plastic deformation. That means here generally brittleness is opposite to ductility and malleability. So there the plastic deformation occurs, where here no plastic deformation or a very negligible plastic deformation. So immediately it will break. So if take a glass, when we try to pull it out, then immediately it will break without any deformation. Similarly cast iron. So this is the brittleness. And the next one is impact strength. It is a capability of a material to withstand a suddenly applied load. That means the loads are different types: gradually applied loads, suddenly applied loads, and in the suddenly applied loads also we have different types. That means when the strength, the bearing capacity of a material when it is subjected to suddenly applied. Some materials are strong when the load applied is gradual. But some materials may not be, though they are very strong, their strength is good for gradually applied load, but they may fail when the load is applied suddenly. Therefore, the impact strength is the capability of the material to withstand a suddenly applied loads, and it is expressed in terms of energy. So, this is what impact strength. That's why for example, when we are making a bumper of a car or its chassis or whatever it may be, when accident takes place, the load applied here is impact load, that is suddenly applied. So if that chassis or car, if you have a good impact strength, then it will bear that load. If it does not have, then it will fail, the fracture occurs. So this is what we have, the impact strength. The next mechanical property is fatigue. And fatigue also generally we will be using when we are tired or something, fatigue. So fatigue is the weakening of a material caused by repeatedly applied loads. So when a load is applied repeatedly, suddenly applied load is different, gradually applied load is repeatedly. That means at a particular pace, when we are applying repeatedly, then it is called, that may fail. Though the applied load is a little amount, but when we are applying repeatedly, that may fail. So fatigue is nothing. It is a progressive and localized structural damage that occurs when a material is subjected to cycling loading. Cycling loading means repeated loading. So generally it's progressive and localized in nature. So at a particular local area, localized manner, if it is repeatedly load applied, then the fracture may occur, it may fail. So this is what a weakening of material caused by repeatedly applied loads is called. Next one is called creep. What is a creep? It's a tendency of a solid material to deform permanently under the influence of loads. That means, and generally it occurs as a result of long-term exposure of high levels of stresses that are still below the yield point. For example, a load is applied on a material, and though the material can have enough strength to resist this load, though it's the strength is more, it can bear that load, but when it is applied for a long time, that means when it is exposed to a high level of stresses for a long time or a period of time, it may fail. So this is what the tendency of a failing, deforming permanently or fail is called creep. And the term creep resistance is nothing but creep resistance to creep. That means it can be defined as the material's ability to resist any kind of distortion when under a load over an extended period of time. So it's ability of the material to resist any kind of distortion without any permanent deformation or plastic deformation. It can resist even for longer times. Then we say that the material is creep resistant. So this is what the creep resistance is. And the last mechanical property that we are dealing with is resilience. What do you mean by resilience? Resilience is the ability of the material to store energy within the elastic limit is called resilience. That means when it is subjected to a load within the elastic limit. What do you mean by elastic limit? When a load is applied and if the load, it will deform. When the load is removed, then it will bounce back to its original shape. So up to which load, up to certain load only, it will regain its shape. Up to that point, we will call it as its elastic limit. So the ability of the material to store energy within the elastic limit is called resilience. So this is what we have. So we'll stop here and we will continue with next topics of the same subject and same chapter in the coming days. So thank you very much for when watching this video. So if you have if you liked it, so please share with your friends. So, thank you very much. We will come with the remaining parts and remaining sessions. Thank you.